minimize this. Play. Where's the play button? Okay, so today we will be doing brute force search and binary search. I think it's fairly straightforward. Okay, so brute force it's essentially exactly what it sounds like. You are it's a search algorithm where you're basically going through every single available possibility. So some examples of this would be, like, the best way to explain it would be through analogy. So I have some examples listed. One would be trying every single item on a menu to see which one involves fried chicken. Another one is trying every single pair of shoes in a store to see which one you want to purchase. And then another example is knocking on every single door on a street until you find the correct house that you're looking for. So you're essentially going through every single possibility without, I guess, like filtering or categorizing it first. Usually it takes a long time. I guess it would kind of just depend on like how big of the stuff you're looking through is, but that's why you wouldn't want to do it. So like the chicken example, like if you're actually sitting down in a restaurant looking at a menu, you wouldn't want to go through every single item on the menu. You'd probably just like skip to the chicken section first and see which one has fried chicken versus like grilled chicken or whatever. Or even trying on the shoes, you wouldn't go to like a Nike store and try every single pair. You'd sort it by, say, men's and women's shoes, or you'd sort it by the size first. That way you don't have to go through every single one. So that's brute force. You don't want to do that. It has a terrible time space complexity. Yes, do not do that. Bad stuff. What you do want to do sometimes is binary search. So this basically, it works for a sorted array. So sorted in descending or ascending order. You can't really use it without having a sorted array already. And it'll just return the position of a specified value. So like the index of the element that you're looking for. It's O complexity, or big O notation, is going to be log n, because each time you do it, the problem space gets halved. So I think visually is the best way to explain it. If you're looking at the screen, let's say we're starting with this first array at the top, and this example will be looking for the number 20. So essentially what you're doing is, here I have a list of 15 numbers in an array. It's already sorted from ascending order. During binary search, you will have, it'll start off with, you have something set as a lower, which is going to be the least, the smallest number on the array. And then you have the higher, which is in this case 98, and it's the highest number on the array. Binary search will set a midpoint, which is literally just the number in the middle of it. If you have a set of even elements in an array, then you just round down. But yeah, so you have lower, middle, and higher. And it'll test and say you're looking for number 20. It'll look for the middle element and say, okay, does 35 equal 20? If it does, then you found your element and then you exit the search. If it doesn't, then what it does is it takes the middle element, 35, and it compares it to the element that you're looking for. So does 35 equal 20? If 35 is higher than 20, then what it does is it moves this higher limit to become the new middle. So that's what happens here. You're essentially chopping off this whole second half of the block because we don't want to search there anymore. And then it'll take a new middle. So between 4 and 35, it'll find the middle element, which is, in this case, 15. And then it just repeats itself from there. So it'll say, okay, is 20 equal to 15? No, it's not equal to 15, but it's higher than 15. Then your lower limit will actually move to become the middle. So that's what happens here. And then we have a new middle limit. So now we're searching between 15 and 35, and we say, and the middle limit, the middle number is 25. And then we're saying, okay, does 20 equal 25? If it does, then we exit, but in this case it doesn't. So 25 will become the higher limit since 20 is less than 25. So we're just continually chopping this array down. And as you can see, we're halving it. So we started with 15, then we had 1, 2, 3, 4. Okay, then we had 8, and then we had 4 elements, and now we have less. And finally, once we get to 20, that's when it exits. Does that make sense?
Yes. Good job.
Okay, great. So essentially, you're just halving it down until you get to the number. So here's we'll take a look at some code on it. Oh, I already have it on here. Okay. This code is actually already in the Slack channel from it's like from Robin's list of all the, I guess, just all the REPLs he has. But yeah, so let's go through this. Let me minimize this a little bit so you can see. Okay. So the way this code works is it receives an array as a parameter and then the element that you're searching for as a parameter. So it starts with, you have your start point, end point, and then the middle. Start we'll say is 0 in this case, and then the end is the array length, because array length minus 1, because you want to get that last index. The middle is bound with a midpoint function. So that's actually down here. You're just doing the last two, the first element, the second element, and then halving it. So you just find the middle one, and then it'll floor it if you have an even number of elements. But yeah, so you have your start, your end, and your middle. And then this is, I think, for here is, I guess, what is important. So you're in a while loop, and essentially it's saying, while your middle element does not equal the element that you're searching for, and your start is less than end because you don't want to have like a weird array. But yeah, while your middle element doesn't equal the element that you're looking for, then you want to continue doing this loop. So for here, if the element that you're looking for is less than whatever the middle element is, then it changes the endpoint to be the middle element, the middle index. Otherwise, if your element is greater than the middle, the start point becomes the middle. So it either changes the lower limit or the upper limit dependent on if the element that you're searching for is greater than or less than the middle point. And then here, this is just another search for the middle point. So some examples, I mean, I can just run this to see. So in these examples, this is your array, and it's looking for 28. So what it does is it looks for, you have 2 as your lower limit and 30 as your upper, and then your midpoint would be 13. And you see that 13 is less than 28. So then this would become the lower limit. And then you're only searching 13, 15, 28, and 30 for 28. So you only look for half, within half of the array each time. Does anybody have questions on this, on the code specifically, or just general concept for binary search?
No, I don't think so.
Okie dokes. Where's that one? Okay, that is basically it. Thoughts or anything?
That's good. I feel like I don't know. I feel like that's not too difficult to grasp, I feel like.
Yeah, I don't
Just
think I personally think it's fairly straightforward.
yeah,
Um, I mean, you just half it until you find something.
yeah.
Yeah. Alrighty, that is it then.
Cool.
Oh,
Good job.
If you guys want this, it's in the I can send this over as well, but
Cool.
it's also in the big thing with all of Robin's stuff.
You share your sites too.
Yes, yes, I will share my slides as well.
And
Okie
make sure
dokes.
that you're actually like sharing them and not just grabbing the share link. We've had a lot of problems with that. So you have to like actually turn on a thing in there that's like, hey, share this. So
Okay. Yes.
it's real annoying.
Share.
But
Copy link.
so I think you have to
Wait.
change to anyone with the link on the and then that link should work.
Okay. Okay. I will send that over to you guys, and then I'll send the rep bullet too. Alrighty.
Very good. Thanks, Skylar.